Hi, this is Paul. We're doing Leetcode, must know interview questions. Today's challenge, product of array except self. And this is rated as a medium challenge. Given an integer array, nums, return an array answer such that answer at index I is equal to the product of all the elements of nums except nums at index I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. That's actually kind of suggestive of a solution approach when they mention prefix and suffix. You must write an algorithm that runs in O of n time and without using the division operation. Okay. So let's talk about what's not going to work. One obvious solution to this is just write a nested loop. It's gonna take n passes through the array, and every time through, it'll multiply all the numbers except the one that you're trying to omit. Okay, so nested loop, it's O of n squared, so we can't use it. Also, if we could use the division operation, we could take one pass through, multiply all the numbers, and then take a second pass through and divide the product that we obtained on the first pass by, each element in turn, each element that we want to omit. It's O of n, but we're not allowed to use division. So let's see, what else do we have here? Okay. Follow up, can you solve the problem in O of 1 extra space complexity? I think so. Topics. Sometimes, yeah, it's good to look at the topics. Actually, we get down to topics. But if you click on topics here, it'll come down and say array prefix sum. We're not going to do a prefix sum, but we're going to kind of do a prefix product, also a suffix product, and see how that works. What else is there? I thought there was one other thing I wanted to call out here, but maybe not. Oh no, I remember. There's an edge case here if the array is of length 1, because the product would turn out to be 0, but the constraints here say that the array will be of at least length 2, so we don't have to worry about that. All right, this is the array from example 1. Let's see. We've got an extra variable that we're going to use. I called it CURR for current, but other choices are possible. We're going to have to create a second array of the same size as the first array. So let's do that. And we're going to initialize current to 1. We're going to take a loop through this array starting here at index 0. And for each number in the nums array, well, no, let me say that a different way. For each index, we're going to set the result array, the answers array, to the current value of the CURR variable. Right now, it's 1. We're also going to update the cur variable to itself times the current element of the nums array. So current right now is 1. We're working with the first element of the nums array, which is also 1. So current stays as 1. All right. And then we advance here to the next element. Again, the first thing that we do is take the value of cur, put it in the answers array, and then update cur to itself times the current element in the nums array. So it is now going to become 2. Advance to the next element. We put cur in the answer array and update cur to be itself times 3. So cur becomes 6. All right. Advance to the last element and put cur in the results array. We could update it, but since we're done, it doesn't really matter. All right. So that's the first pass through the array forward. So to give us a prefix array. We're going to go backwards and, essentially construct a suffix array and the solution at the same time. So let me get rid of this stuff. We're going to reinitialize cur to 1. Now, as we go through this time, we're going to update the answer array a little bit differently, and that is, and let me actually let me erase those two. Let me take those off of there, so I can say, all right, we're going to start here. We're going to go backwards. For each element, we are going to update the answers array to itself times current. Okay, so we are here. 6 times 1 is 6. So we leave it the way it is, and now we update current to itself times the current element of the nums array, which is 4. So current becomes 4. Move to the next element. We update results to itself times current. Let me mark it here as well. So that is 2 times 4. So this becomes 8. All right. Move to the next element. I might as well mark this on both of them. Oh, wait. We got to update. I'm sorry. We've got to update current. Before we leave here, we've got to update current to itself times the nums array. So current, whoa, I could do that. All right, so it's 4 times 3 is going to be 12. All right, now we can advance. Result equals itself times current. So 1 times 12 equals, I could squeeze a 12 in there maybe, but it's going to be messy. Let me take it off and rewrite it. It is 12. And update current to itself times the nums array element, which is 2. And so that becomes 24. All right, now we advance, and result becomes itself times current, which is 1 times 24. 24, 12, 8, and 6. Is that right? So 4 times 3 is 12, 24. Yeah, 4 times 3 times 1 is 12. 1 times 2 times 4, 8. And the last one is 1 times 2 times 3, 6. So that should work. Let's try coding it. All right. So we need, let's see. We need a new array. We need a new integer array called answer. And that is going to be new int. Same length as nums. Nums dot length. We need a variable. Let's call it cur and set it to 1. All right. Now, two for loops. First time is I equals 0. I is less than nums dot length I plus plus. And each time through the loop, we set answer at index I to cur, and we update cur as cur times nums at the current index. Okay. Next, reinitialize cur to 1 and do the backwards for loop. So for int I equals nums dot length minus 1 I greater than or equal to 0 I minus minus. It's almost like this, almost. Whoops. Come on. Almost like this. So answer does not equal cur. Answer equals itself times cur. And then cur equals itself times nums I. And then we can return answer. All right. Let's run it. Put this up a little bit so I can see it. I forgot a semicolon there. Run. Compile error for I. What's wrong with that? Oh, typo. Okay. Semicolon. Try it again. All right, basic case accepted. And submit. I don't see where the, oh, that's funny. Usually it shows up over here. All right, accepted. One, I guess those are milliseconds. Okay, so that is the solution. Why does it show up over there? Maybe there's not enough room. What if I scoot this over? Would it go over there? Okay. Anyway, that is the solution. Please feel free to like or subscribe, and see you next time.